welcome to Introduction to Aerodynamic Objects Tutorial 8, Flight Control. And in this tutorial, what you're going to do is set up control surfaces and connect these with player inputs. Then you're going to use static and dynamic wind tunnel experiments to verify control response. And then lastly, evaluate aircraft handling qualities in free flight. So our scene diagram is pretty similar to tutorial 7, the only difference now being that we've got player inputs going into our aircraft manager and the tail and wing have aerodynamic control surfaces on them. So here we are in Unity at the end of tutorial 7, and what we're going to start off with is setting up the aircraft. And first job is to replace Aircraft Manager tutorial 7 with Aircraft Manager tutorial 8. So if we do that, and this is same as before, we've got a center of mass marker and a prop hub, but you'll see here now we've got some flight controls that we need to connect up. So first off, let's connect our center of mass manager as before and our propeller. And because we're going to be connecting up various things to Aircraft Manager, what I'm going to do is pop it out now by using the 3 dots icon and properties. So we've got our separate window there that we can access at any time. So we need to get the user inputs to connect with our control surfaces, and we do that via a player input component. So if we do add component and search for player input, and then we need to connect this player input component with the relevant actions. So if we click on the target icon there, the options that will come up if your project is installed in standard way, we've got the showcase user controls, but we want to use the AO tutorial user controls. So double click on that. And if we just have a look at what's there, these have been set up for you to use, but we have various actions. And so looking on this one, if we've got the roll, negative left arrow keyboard, positive right arrow keyboard. So what that's saying is my roll control input is using left and right arrows. Great, so we're now ready to set up our first control surface, and we're going to do the elevator first. So we go to the aircraft, and I'm going to do alt click to select everything because our controls are buried quite far down. And what we need to do is find fuselage, tail, and then horizontal stabilizer, and then go down to aerodynamics, and that is where we're going to put our elevator. We do that by adding a control surface component. We did this back in the first wing tutorial, and by default this comes in and it has a surface chord ratio of 0.2, so you need to make sure you've got gizmos on to see this happening, and it means that the control surface is 20% of the chord of the overall surface. We also want to put in the graphics, so let's do that. Create control surface graphics, and so now underneath there we've got some other additional graphics components, and we need to remove the mesh render on the original one so that doesn't go over the top of it. Okay, so that's set up the control surface in Aerodynamic Objects. So if we moved the angle there, it would move the control surface in flight. But what we need to do to make this a playable item is we need to connect it up with our player inputs. So to do that, what we're going to do is drag the control surface component onto the relative slot in Aircraft Manager. So checking I've got the right one, horizontal stabilizer, aerodynamics, I'm going to drag that in, and it is the elevator. It's quite easy to drop it on the wrong slot or get things in the wrong order. It's always a good idea to, if you double click on that, it'll tell you where it's come from. So elevator, and it's come from horizontal stabilizer, aerodynamics. Okay, so that's all good. One thing we need to do whilst we're here, in the previous tutorial we had the tailplane set at an angle of 8 degrees to get it trimmed in free flight. Because we're putting our own flight controls on, it makes sense to not have such an aggressive trim, so we're going to have the tailplane set at 5 degrees. So we've created a control surface, we've connected it up with Aircraft Manager. What we need to do now is verify that it does what we expect it to do. So what we're going to do is set the aircraft up as though it was in a static wind tunnel experiment, so we can easily see that the controls are doing what we expect. And to do that, I'm just going to lift the aircraft off the ground so we can see it properly. And we're also going to be using the game view to see what's going on. When you're using control inputs, they only work if the game view is in focus. So the workflow changes slightly in that we need to be working in the game view now when we're interacting with our model rather than the scene view. So let's set that up. First thing we're going to do is set up the cameras so that they work as we want in game view. So if we go to our cameras, and the one we're going to use most often is the aerial orbit cam. Depending on how you set it up before, you want to change these values to something a bit higher. So I'm going to have that so it moves reasonably quickly, and let's make it scroll a bit faster so we can get around more easily. Let's start with it looking at the back of the aircraft, so let's put 120 degrees and a distance. And this just means that whenever we start off, we're in a reasonable place to see what's going on with our controls. We want to turn off auto orbit so it just stays fixed. Another thing we need to do is make sure that the game view is play focused, because we're going to be doing our work in the game view, so it just makes sense to jump straight to that. So that's okay. So our aircraft is going to be fixed in space, and we're going to put some wind on it. So I guess the first thing we need to do is make sure it's fixed. So we can do that just as a cheat way. If we just do is kinematic, it's not going to move. But now we need to blow some wind at it. So if we go to our existing uniform flow component, we can see at the moment, as we left it last, the wind was blowing up because we were trying to do some soaring, but we want it blowing horizontal. So the default there should be just coming in along the z-axis. So that's what we want. And let's have a speed of 5 meters a second. Okay, I think we're ready to turn the wind on and see if our elevator works as expected. So I'm going to hit play. It's going to jump to the game view. Because the orbital camera was default, I can now control the scene using the orbital camera. If I zoom in a bit closer, and if we've done it right, I'm going to do the up and down key for elevator, and there we go. We can see we've got some action. So that shows it's been correctly set up. I'm getting keyboard inputs, and that is moving the control on the aircraft. When you first do this, chances are you'll miswire something and it may not work. You'll have to go back and just check everything's connected up as expected. Okay, so I'm happy that that is doing what I want. If I pull back on the stick, so it's down arrow, the elevator is going up, so that makes sense. And if I push forward, so forward arrow, the elevator is going down, so getting more lift on the tail, and that's pushing the nose down, and that's what I'd want for an elevator. But it's a bit slow, and it's also going a bit too far, so let's get that sorted. So start off with what I'm going to do. If you change the control responsiveness, this is how fast it moves. I've put double that and go back to game view. You see it now moves more quickly, but that deflection is too much. It's acting like a spoiler at the end, so let's reduce that to 0.5. Okay, that looks more like it. Elevator's moving a reasonable amount, and it's moving reasonably quickly. If for any reason it stops working, if you click outside the game view, the input manager doesn't take your keyboard input. So sometimes if it's not working, it may be that. So click inside, make sure you're inside when you're doing that. Okay, the other thing we need to remember is we're setting this up in play mode. So of course, when we stop play mode, it's going to lose these values. You can do copy component, paste values, or just remember what you did. In this case, we reduced the gain to 0.5 and we increased the control responsiveness to 2. So let's just hit stop and retype those numbers in. So we had pitch control gain of 0.5 and control responsiveness of 2. Great, we got ourselves an elevator. Next job is set up the rudder. So if we find that in our hierarchy, so we've got tail and vertical stabilizer, so that's where the rudder is going to live, and the aerodynamics is where we're going to put the control surface. So similar to what before, same process. I'm going to do add component, control surface. I am going to create control surface graphics. I'm going to remove the graphics on the existing control surface. Then I'm going to connect up the control surface to the aircraft manager. So I'm going to drag in the control surface reference, and this time it's going to go to rudder. I'm just going to check it's gone to the right place. That's good. Okay, that's all done. So let's turn the wind on and see if that behaves as expected. So this time the rudder is on the A and D keys. So if I'm doing left rudder and that's right rudder, so something's happening, that's good. But let's just check it's going the right way. So I'm hitting A, so I want to turn left. But what we can see from there is that the, if I do it the other way, D, if I want to turn right, it's actually producing a side force on the fin that's going to pull the nose to the left. So what that's telling me is that my controls are rigged up the wrong way. And that's fairly common when you're setting up an aircraft. There's always two ways of setting up the controls, and one of the first jobs is to make sure everything's rigged correctly in the right direction. So we can correct that by, if we go to your control gain, if we just put a minus in there, go back here, I'm now doing left rudder, and that's correct now. So the tail's going to swing to the right and the nose is going to go to the left. D, that now the tail is going to go to the left and the nose to the right. So that is correct. Okay, I'm going to stop that and then make that change permanent, out of play mode. But the other thing I'm looking on here is that rudder looks a bit small. If you see rudders on a lot of aircraft, particularly on aircraft going back to the First World War, they had enormous rudders on to give themselves lots of yaw control. So let's have a go at changing that. If we go to aerodynamics in the hierarchy, and we change that by changing the surface chord ratio, and let's go for it and have 0.4 on there. And you can see immediately with gizmos on, you can see the chord line is changed, but we also need to recreate the graphics so that corresponds to that change. Okay, let's try that. So I'm using A and D now, so yeah, we've got a massive rudder, so we should have huge amounts of yaw control on our aircraft. Great, so next up, let's collect up the ailerons. So these are on the wings. So if we find the starboard wing first, aerodynamics, add a control surface, add the graphics, and remove the existing graphics for the wing, and same again on the port wing, add a control surface, add graphics, remove the old graphics. Then we need to connect up, so port wing is going to be the port aileron, and the starboard wing is going to be the starboard aileron. Let's double check that, that's good. Okay, we're all set up. Let's try that. So the ailerons are on the left and right arrows. So if I do left arrow, the starboard aileron has gone down. We've got more lift on the starboard wing, so that's lifting it up. And the opposite has happened on the port wing. So that is actually the effect we want. So if I want to roll left, I'm hitting the left arrow key, and this aircraft is now going to roll to the left. And similarly, if I do right, it goes the other way. So I'm happy with that, but the control surface deflection is too much there, so I'm going to reduce that. Let's try. So we've got roll control gain. It's the right sign, but let's just make it a bit smaller. Okay, that looks a bit more sensible. Hit stop. Make that change permanent. Great, so we've set up our controls. They work in the right direction and they're about the right magnitude. What we need to do now is verify that they work in a dynamic sense. What we're going to do is a dynamic wind tunnel test. So the center of mass is going to be fixed so it can't translate, but we're going to allow the aircraft to rotate around the center of mass. And we're going to do that by changing the constraints on here. We're going to undo kinematic, but what we're going to do is freeze X, Y, and Z. Okay, let's give this a try. Okay, that's looking promising, although you may have noticed when we turn the wind on, the aircraft is yawed to one side. And actually, if you look pretty carefully, you can see our fin has got an angular offset on it, and that's something we used in the previous tutorial to make the aircraft turn on its own. Since we're now controlling the aircraft, I think it makes sense to turn that off. So what I'm going to do is remove that fin rotation. So fuselage tail vertical stabilizer geometry, and there's the culprit there. It's been rotated 5 degrees around the y-axis. Let's set that to 0. So now our fin is straightened up. And there we go. We're flying. It's got a little bit of drift on it, but that's probably because the propellers are generating some sort of torque just because they're sitting there. If we test it, the roll control looks good. Pitch control, up elevator, okay, trims at more lift. Down elevator, trims at negative lift. A and D, rudder makes us yaw, nose left. D makes us yaw, nose right. And we can put the propeller on. And since the propeller the thrust is acting through the centre of gravity, it doesn't generate any pitching moment, but there is a torque reaction from the propeller. So the propeller is creating a drag torque as it's spinning around. So I'm having to put a bit of right aileron in there to straighten it up, to stop it rotating when we have the propeller on. But other than that, it's all looking promising. Okay, so I think we're ready for our flight test. So a little bit of work to set the scene up, but let's get on with that. First thing I'm going to do is turn the light down. It's a little bit bright, so I'm just going to reduce that to 85%. That looks better. And we don't need this, but let's add in a runway to give us some context. And if I close up aircraft, and if you look in the prefabs folder, you should find there a runway, and if you just drag that into the hierarchy view, it'll just be dropped in on 0, 0, 0, and that's in a good place for us. And what else do we need? Well, since this is now a controlled aircraft, I think we probably need a pilot. So Aeroman has a brother, and if you look down here, pilot sitting, if we grab that and drag that on top of the aircraft, see Aeroman pilot appears. He's the wrong way around for the aircraft, so let's quickly rotate him 180 degrees so he's facing the right way. And just to make him comfortable, we'll make him sit on the CG marker. Okay, there we go. What else? Because our aircraft has got a bit more stuff on, I think it's going to be a little bit heavier, a bit more realistic to make it heavier anyway. So it was 10 kilograms, which is pretty light. I tell you what, let's just double this to 20 kilograms. So it just means it's going to fly a little bit faster, but that's good. What else? Let's get the aircraft positioned on a suitable place on the runway. So we're going to start off down the end there. So let's drag it down. Just leave it slightly above. And let's get Aeroman out the way as well. Stick him on the side so he can watch behind. We want our aircraft on the centre line. Notice it's got a bit of an offset in X, so I'm just going to zero off the X so it's on the centre line. What else do we need to do? We're flying a little bit faster, so our arrows are going to be bigger just because the aerodynamic forces are larger, and just so they're not too distracting, what I'm going to do now is reduce the scaling on those arrows so they're not too large. So what I'm going to do is multi-select the aerodynamic components of the wing and tail. So I'm going to select the horizontal tail, control, and then the vertical tail, port wing, starboard wing. And the thing we want to change here is the lift arrow. So I'm going to reduce its sensitivity by a factor of 5. So it's out the way, so 0.02. So other things on our pre-flight checklist, we need to make sure the aircraft is released so it can move. So go up to aircraft. It's not kinematic, but its position is frozen. Let's release it. What else? Since we're doing some proper flight experiments, I think we need a windsock to tell us which way the wind is blowing. So if you go to your prefabs, you should find a wingsock there. I'll drag that in, stick it somewhere near where we're taking off. And let's set up our cameras so that they behave as we want to. So we're going to be using the ground camera to start off with to see what's going on. Let's move it a little bit closer to the action and change some of its values. So I'm going to change the field of view to 40 and the default distance to 40. That'll give us a better view. The aerial orbit cam is what we set up before, but this time actually let's put on auto orbit, so it will go slowly around our aircraft as we're flying, so it's imagining drone is filming us as we're flying. And the chase camera, we want it behind the aircraft, so I'm going to drag that back. We can see in our preview where we are. It doesn't matter exactly where you put it, but just sort of somewhere behind the aircraft. Okay, I think we're nearly ready for a takeoff, so a quick checklist. We've got our aircraft set up with our controls. We've verified in a dynamic wind tunnel test they go the right way. We have got our aircraft positioned in the right place on the runway. We've removed the chocks as such. We've released it so it can move. We've got our windsock, and actually for our first flight test, it always makes sense to test in still air conditions. So what we're going to do is actually turn the wind off for our flight tests, and that makes it a bit easier. Okay, and one thing we want to do for our first flight test, we want to use the ground view as our default. So if I go to the cameras, I'm going to set ground view as our default camera. Okay, let's give this a try. Okay, so our first takeoff, so I'm going to put a bit of throttle on. Moving forwards, getting some lift on the wings, a bit more throttle, and there we go, we're away. So I'm controlling it with the up and down arrow keys, so right arrow key to go right, down arrow key to pull back on the stick. And obviously if you have a joystick or something, it's much easier to control, but you can do it with a little bit of practice just by sort of tapping the keys. Let's look at our other views. So our view from behind, so that's right aileron, that's left aileron. You can see that they're both working as expected. Pull back on the stick. It's going up. Push down on the stick. Going down. And left rudder, so yours that way, right rudder, yours this way. And you can see why it's really important to test these things on a gimbal in a sort of dynamic wind tunnel test where you fly, because when you're flying there's an awful lot going on. It's actually quite hard to verify the controls are doing what you think they should be doing. So doing your static and dynamic wind tunnel tests is a really important part of building up confidence that the aircraft you're building is going to do what you hope it does. Okay, let's bring it in for a landing. Reduce the throttle a bit. Okay, that was not a very good landing, but we're back on the ground. Okay, let's set up some wind for our flight test. I'm just going to go back to the speed we had for the wind tunnel. So that was 5 meters a second. The aircraft is flying anywhere between 10 and 15 meters per second. So it's a steady breeze, but we should be able to make decent headway in it. Let's try that. There we go, our windsock's blowing backwards and our aircraft is going back because we don't have any brakes on our aircraft, so the drag is just pushing the aircraft back. But if we start our engine up, we can go against the wind, and there we go. We're taking off into wind, and that's actually, it's a very short takeoff anyway, but that's an even shorter takeoff when you're taking off into the wind. If I go to, let's go to orbit cam, and so it's a real moving air mass. Once we go downwind, we're moving much faster relative to the ground, so our ground speed goes up. So you can see we're going really quite fast, and then we're going to come around into wind, and you see we're being blown downwind, and we've overshot. There we go, come back. Feel the throttle. We're into a bit of a headwind, so we should come down pretty quick. Okay, bumpy landing, but we're back on the ground. Great, the last thing we'll try, since we're flight test engineers, let's put some real wind on. So now let's make it a turbulence. So we're adding turbulence magnitude of 1 meters per second on that. So it's not a huge amount, but it's going to make the air sort of bobble around a bit. Okay, you can see our wind field arrows there bobbling around. Yeah, it's chewing out the propeller a little bit. And there we go. We're flying in turbulent, gusty conditions, but we're doing well. Our flight controls are working as we would expect, and we've got a fully functioning aircraft. Okay, there we have it. We're back on the ground eventually. Not the best landing in the world, but probably one that you could walk away from. And what we've seen in this tutorial then is how you take an aircraft built out of aerodynamic objects, and by adding control surfaces to it and connecting those with player inputs, you can make a fully controllable aircraft. And we've also seen the development process of testing things in a static situation and a dynamic wind tunnel experiment, and then finally going to free flight. So that brings us to the end of this tutorial. In the next tutorial, what we're going to do is a scrap heap challenge. We're going to try and rebuild this aircraft in a different configuration to show the flexibility of using aerodynamic objects for aircraft design.